Welcome back to Urevise, where we talk about everything exams. Let's take a look at question 1 from the 2016 exam. According to the examiner's report, question 1, 80% of the candidates who sat this paper managed to get this one correct, which means only 20%. Of about 4,999 students, I think that was the number, did not actually get this question right. The question reads, the decomposition of hydrogen peroxide in a closed system is represented by the equation below. So we've got hydrogen peroxide decomposing, forming water and oxygen. Delta H is less than 0. Right, which means delta H is negative. That's the other way of looking at this. You need to interpret this properly, which means as well this reaction is exothermic. When a reaction is exothermic, it means energy is a product in that reaction. It's a good idea to have this there so that you can clearly visualize what's going on. Its question reads, which one of the following will increase the equilibrium yield of oxygen? The first answer reads decreasing the concentration of hydrogen peroxide. If I decrease the concentration of hydrogen peroxide and I apply Le-Chatellier's principle, or LCP, it tells me that the system will partially oppose this imposed change, and it will try to build back the concentration of hydrogen peroxide, and to do so it consumes the products going back this way. As a result, the equilibrium yield of oxygen will decrease. So let's take a look at this graphically for those of you who might not be quick to follow the interpretation I'm giving here. I'm going to do all these here on a graph so that you can picture what's happening. I'm going to just assume that hypothetically I'm starting with this system has got a lot more oxygen than hydrogen peroxide. Some of you will be thinking, why would you do that? Why would you say there's a lot more oxygen? I don't know. It just works whichever way, because if you find a system at equilibrium, you impose the change. How the system responds doesn't matter which one do you have more of at equilibrium. So if we look at this case here where we decrease the concentration of hydrogen peroxide, the concentration of hydrogen peroxide has been decreased. The system will partially oppose that by consuming the products, which is oxygen. And that will try, as that happens, the concentration of hydrogen peroxide will try to build back up. So as we can see, the amount of oxygen, the concentration, the partial pressure, whatever we are measuring this in, will decrease, which means the equilibrium yield is not changing. Some of you would ask me, why is it that I'm leaving out water? Water is a pure liquid. If I was to draw its, let's say the concentration, which is the density of water, it will just be a constant line that runs along. So it's not part of this, which is another reason why we don't include it when we write the equilibrium constant, because it has got pure solids and liquids have got constant densities, which is constant concentration, in other words. Now, the next answer, which means we can eliminate part A, right? Answer A, so not part A, answer A. So what it means here now is I've got a 1 in 3 chance. This is very important if you start to confidently eliminate wrong answers during a multi-choice exam. In a multi-choice exam, you are increasing your odds. And when you increase your odds, what happens? You are actually controlling your emotional intelligence. You're not going to be panicking in the exam. Now, the next question says increasing the total pressure of the system. Now, if I increase the total, how do we increase the total pressure of any system? By halving the volume or decreasing volume, not having necessarily, by decreasing volume. So if I decrease the volume of the system, it only affects the gaseous components of the system. Everything else is not affected by pressure, because obviously from the basic knowledge we have, these are not compressible, so gases will be affected by that. So if I decrease volume, remember we increase pressure by decreasing volume, or decrease pressure by increasing volume. If you add particles, you are changing concentration, you're not changing pressure. That's how we look at it at this level. Now, so when we increase pressure, it means oxygen is going to increase. Let's say we are using partial pressure, or concentration is going to increase. And what will the system do? The system will partially oppose this imposed change according to Le Chatelier's principle, and it will decrease that concentration of oxygen. Right. Let's admit that, of course, yes, the oxygen will slightly be more than it was at this state of equilibrium now, but overall, it's not a, a significant increase. But let's see, if this was the only answer that was there, I would say yes, this is the correct answer. So I'll leave this one for now. Now, we know that when this happens, this will also what? Increase, because when you consume oxygen, you form more hydrogen peroxide. Now, let's look at the next answer. I'll leave this one there for now. C, decreasing the temperature of the system. When I decrease the temperature of the system, basically I'm affecting products because I'm decreasing this component, which is energy. When the energy of the system goes down, the system will try to oppose that imposed change by shifting equilibrium towards products, which means the concentration of oxygen will increase, or the amount of oxygen will increase, while this one will be decreasing because it does, or consuming this one. So this one here is more correct than this one. Why? Because we can see a significant increase of equilibrium yield of oxygen compared to this one here, where if we assume it's starting, it was at equilibrium here, we change that, it drops. This is the only increase, but this one, if it starts at equilibrium here and then we increase temperature, we decrease temperature, this is going to increase remarkably, right? So appreciably, that's the word I'm looking for, not remarkably, appreciable. It's an appreciable increase in the amount of oxygen. So I'll say this is the most correct answer. That means I can now eliminate this one. Adding an inert gas to the system. If you add an inert gas to the system, yes, the overall pressure of the system is going to increase. But when the overall pressure of the system increases, it's not going to affect the partial pressure of oxygen. Oxygen will maintain its own partial pressure because the system, so let's say, look at the system here. If I've got oxygen, which has got, let's say, pressure which is equal to X, right? And I inject an inert gas, let's say neon, which comes in with a pressure equal to Y. The total pressure of the system is going to be the partial pressure of neon plus the partial pressure of oxygen. And these two partial pressures will be Y plus X. It doesn't matter which one I write first, but I just wanted to write this underneath this one, the respective elements. Now, we can see that the partial pressure of oxygen remains X, this one remains that, but what changes is the total pressure of the system. So this one will not affect any system at equilibrium. If you add an inert gas to any system, it will increase the overall pressure, but it doesn't affect the partial pressure of the gases that were there already. Now, so that brings us to the end of this question because we got our correct answer as C. So C is our correct answer here. I shall see you when you attempt the next question.
Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.